Hi all, welcome to Malware Analysis. I'm Jay Lavanya, Assistant Professor of CS Department. So in this video, we're going to discuss on the topic called reverse engineering for Windows and Linux system. But before that, so why we need to reverse engineer malware? Reverse engineering, first of all, it's for Windows, such as malware involves analyzing the code or structure to understand its functionality, vulnerabilities, and its potential impact. So, is one such analysis technique that involves disassembling the program's components and functions to gain insight into its behavior, structure, and capabilities. So, this process can assist cybersecurity professionals in recognizing the attack vector of a given threat, pinpointing its infection and propagation methods, as well as crafting effective countermeasures against it. And this process is crucial for developing effective countermeasures such as antivirus tools or intrusion detection system and security patches. And this reverse engineering malware is one such analysis in disassembling the program's components and functions to gain insight into its behavior, structure, as well as its capabilities. Okay, and why we need the reverse engineering, right? So, reverse engineering malware can be particularly insightful for identifying the zero-day vulnerabilities in software which are otherwise unknown to some respective software builders and can be exploited by attackers to gain access to systems and data. Analyzing the malware also enables reverse engineers to identify the exploit code and the vulnerability it exploits. So ultimately helping develop an invaluable resource that allows them to create the patches or other mitigation strategies. Okay. And this reverse engineering malware can also be beneficial for mimicking the techniques attackers employ to avoid detection and propagate it. So, although by employing obfuscation or anti-analysis techniques, malware developers make it harder to analyze their code or reverse engineering the malware, can identify these tactics and create countermeasures designed to detect and prevent some future outbreaks. Okay, so this is the main thing of the reverse engineering, and where this reverse engineering is used, or like common take examples in case of cyber security is that, so this reverse engineering can be used for both offensive and defensive purposes, such as analyzing the malware to develop some countermeasure or uncovering the weakness in the systems. Okay, there is some example. First one, analyzing the malware. First, we have to understand the attack methods. Cybersecurity professional reverse engineer malware to understand how it infects the system, spreads, and carries out the attacks. And this helps in developing the effective countermeasures and preventing the future infections. And identifying the malware families, reverse engineering helps classify the malware into families and identify the new variants. And this allows for better threat protection and streamlined mitigation strategies. And developing signature and detection mechanisms, if you take, like by analyzing the malware's code, a security team can create signatures and detection mechanism for firewall, antivirus software, and other security tools. Okay. And the next one, like identifying the vulnerabilities, software flaws, like reverse engineering can uncover the hidden flaws and vulnerabilities in software and hardware. And this allows for proactive patching and strengthening of security measures before attackers can exploit them. So analyzing the hardware components like the microchip or the other kind of circuit boards can reveal some vulnerabilities. Okay, and that could be exploited by some malicious actors. And threat intelligence gathering, like understanding the advisories Analyzing the malicious tools and techniques provides valuable insights into the methods and motivations of cyber criminals. And anticipating future attacks, this knowledge allows security teams to better understand their adversaries and anticipate the future attack, enabling proactive security measures. And next one, like instant response, investigating security breaches or during a security incident. Reverse engineering can help investigate the event, identify the root cause, and prevent the further damage. Okay, and developing the mitigation strategies, understanding the attack vectors, tools. Reverse engineering helps to develop the strategies to mitigate the impact of a similar incidents in the future. And specific example, if you take like WannaCry ransomware, the National Security Agency's Hydra software was used to reverse engineer the WannaCry ransomware, helping security researchers understand its behavior and develop the defenses. Okay, vulnerability in WhatsApp, like around in 2019, this is a CVE, which allowed attackers to install some spyware remotely, was identified and exploited through some reverse engineering. And next, like equation group tools, a reverse engineering of tools used by the equation group, a cyber attack group associated with the NSA, lead to their exploitation by other malicious actors. Okay, and what are the common tools used is that a Ghidra, like DNSpy, Cutter, DieStorm3, and Dex Translator. So like some ethical considerations if you take here, we have be like ethical hacking if you're gonna use is that here. Reverse engineering is a crucial part of ethical hacking, where security professionals simulate malicious attack with permission to identify vulnerabilities and help organizations improve their security posture. And protecting intellectual property, reverse engineering can be used to understand and modify the existing software, but it's essential to do so ethically and legally, respecting the intellectual property rights. Okay, so this is all about the reverse engineering and why we have needed. So as we have already explained, so why it is needed. Okay, so this case is rare, in cybersecurity or whatever creations. And there are some malware where you can inside full support some zero-day vulnerabilities. We have to use some statics to play a part of it. Okay, so that is what we will be discussing. And this why we need reverse engineering. We primarily to understand the functionality and design of existing product, systems or software, often for improvement, innovation or security analysis. It allows for the recreation of flaws design, analysis of competitor products, and identification of vulnerabilities. It also helps in cost reduction, enhancing the product quality, and adapting systems to some new environments. And understanding and improving the existing products and product analysis and improvement. So reverse engineering helps to analyze the existing products to understand the functionality and identify the areas for the improvement and optimize their design. And second one, absolute product support. So it enables the recreation of absolute products or parts when the origin manufacturer no longer supports them. And extending product life cycles and reducing cost and cost reduction by analyzing the product components. A reverse engineering can identify opportunities to choose cheaper or more readily available materials or manufacturing processes, reducing overall cost. Okay, and next, like if you go for some product redesign, it allows for the redesign of products to meet the current standards or the technical requirements, or we incorporate some new technologies. And next one, digitization of design. So reverse engineering is used to create some digital models of physical products, enabling some on-demand reproduction, digital inventory management, and compatibility with some modern manufacturing processes, especially in industries like automotive and aerospace. And second one, like if you go for like some competitive analysis and innovation, studying computer design. So reverse engineering allows companies to analyze the computer products to understand their design, functionality, and manufacturing processes, which can inspire innovation or identify the areas for competitive advantage. Okay, and accelerating product development. So analyzing the existing products can speed up the prototyping and optimization processes in product development. And third one, if you take like the security and compatibility, like reverse engineering is a crucial tool in cybersecurity for analyzing the malware, so identifying vulnerabilities in software and hardware, developing the countermeasures. So system compatibility, it helps to ensure the compatibility between different systems, especially when dealing with legacy systems or integrating new components into some existing infrastructure. Okay. And recovering lost data in cases of damaged or inaccessible data carriers, reverse engineering can be used to recover the lost data or the source code. Okay, like other applications, if you take like technical documentation, reverse engineering can be used to create or update some technical documentation for products or system where it is missing or inadequate. Okay, and educational purposes, so reverse engineering is valuable for developing analytical problem solving and research skill in some education and scientific settings. Okay, so this is all about why we needed reverse engineering malware. Okay, and next one, so here in this particular topic we are going to discuss on techniques for reverse engineering malware. So first one is that static analysis, and second one dynamic analysis. Okay, so the choice of this analysis technique, it depends on the type of malware being analyzed and the information that needs to be gathered. While both static and dynamic analysis techniques have their benefits and limitations, leveraging a combination of both static and dynamic analysis technique is often the most effective approach for analyzing the malware. Okay, like analyze technique, if we go for the static analysis, the benefits is that it offers insight into the structure and behavior of the program, and it can be performed without executing the program and less resource intensive than dynamic analysis. And limitations: cannot detect the runtime behavior and ineffective for analyzing the malware with some anti-debugging techniques, and it may produce some inaccurate or incomplete code during some decompilation. And when to use is that for initial analysis of malware to understand the structure, logic, and behavior of the code, useful to reverse engineering who may not be familiar with the programming language used in the malware code. And in case of dynamic analysis, if you are using is that it offers some insight into the behavior of the program during runtime, and it helps to detect the runtime behavior and interaction with the system, and ability to identify and analyze the anti-analysis techniques used to evade the detection. And limitations is that it can be resource intensive and time consuming, and may not accurately reflect the behavior of the malware on a real system. And when to use is that for monitoring program runtime behavior and identifying the anti-analysis technique, or for detecting the root case, identifying the malicious processes, and finding indicators of compromise. Okay, and next one, like static analysis. So in detail we will see. It is the practice of dissecting the binary code of malware sample without actually running it. So this technique helps in comprehending how the malware functions, its capabilities, and what kind of damage it may cause. So there are three primary techniques that is used in static analysis. So first one, disassembly. This process transforms a program's binary code into a human readable assembly code and enables reverse engineers to decipher the structure and the flow of the code. For example, if a reverse engineer comes across malware with an unknown payload, they can use disassemblers such as IDA Pro or Ghidra to examine its binary code and locate its entry point. Okay. So once if it is identified in the sense, analysis of the assembly code can provide insight into how the payload uh, behaves. Okay, and disassembling the tools can also be employed to identify the malware packets, which can use compression and obfuscation techniques to avoid the detection by disassembling the packed code. Okay, so the disassembler reverse engineers can decipher its functionality and create signatures for the future detection. Okay, and decompilation. This process converts the mission code of a program back into a higher level programming languages such as C or C++ to make it simpler for reverse engineers to analyze the program's logic and structure. For instance, to reverse engineer malware samples written in obscure programming languages, analysts can utilize decompilers such as X-Ray's IDA Pro or Ghidra to convert the mission code into a more familiar programming languages. So once this code has been converted to something familiar, analysis of its behavior becomes much simpler. Decompilation tools can also be employed to detect the malware obfuscation techniques, which makes the code more difficult to read and comprehend. So by decompiling the code, reverse engineers are able to recognize these techniques and undo them in order to gain insight into its true functionality. And symbolic execution. So this technique utilizes the variables and symbolic values to simulate the execution of a program. And symbolic execution can be helpful in understanding how the malware code interacts with the system and changes its behavior. For instance, if a reverse engineer comes across malware that employs some anti-debugging techniques, they can use some symbolic execution to execute the code and circumvent these measures. So after bypassing these safeguards, they can analyze the code's behavior to uncover its functionality. Symbolic execution tools can also be employed to detect some zero-day vulnerabilities in the software. By running a program symbolically, reverse engineers can identify inputs that cause certain code paths leading to the discovery of vulnerabilities that could be exploited by the attackers. Okay. And second, we will discuss about the dynamic analysis. So this dynamic analysis also involves executing the malware sample in a controlled environment to observe its behavior. And this technique is useful in understanding how the malware operates and what its capabilities are and what kind of damage it can cause. And there are three primary techniques used in dynamic analysis. The first one, debugging and tracing. So these techniques are useful for recognizing a malware control flow, detecting anti-analysis techniques used to avoid the detection, and comprehending how the malware interacts with the system during the runtime. For instance, when a reverse engineer comes across malware samples communicating with some remote servers, they can use the debugger such as OliDBG to attack the running process and analyze its behavior. Or by setting some breakpoints on the networks, it can also be the reverse engineer can interrupt the traffic between them and analyze its content. So once collected data has been analyzed, they can deduce which communication protocol was utilized between malware and its server. Okay, and tracing tools such as sys internal process monitor can also be employed to track the system activity associated with malware. A reverse engineer can use such process monitors to monitor the registry and file system access along with the network activity. So in order to detect any changes made by the malware and gain insight into its behavior. And second one, like memory forensics. This is the process of studying content of a computer's memory using some memory analysis tools and extracting the information of running processes or memory dumps. And memory analysis tools are typically used for gaining insights into the computer's current state and can additionally be employed to detect the malicious process as well as the rootkit. Okay. And uh, for instance, if a reverse engineer believes that the malware has injected the code onto the official processes, they can use some memory analysis software such as volatility to identify the code and assesses its functionality. And with this approach, they also have the access to processes and DLL loaded in memory. Plus, network related data stored there, instances where a reverse engineer believes that there has been an installation of a rootkit on their system. They can use some recall memory analysis software to detect any suspicious processes or modules loaded in the memory. And next one, like emulation and sandboxing. So sandboxing we have already discussed in the last video. If you're not, you can just check it out, the previous videos. So these are the powerful techniques that enable the malware to be executed within a supervised environment and observe for its behavior. So when used together, these processes collectively help us comprehend how malware operates, what harm it can cause, and how best to defend against it. Okay. For instance, if a reverse engineer comes across a malware sample that installs a rootkit on a system, they can use an environment such as the Cuckoo sandbox to execute it and analyze its behavior. And this provides a control setting where malicious code can be executed without impacting the host system. So once understood, researchers can devise strategies to remove the rootkits from infected machines. Emulators such as QE, MU can also be utilized to simulate the different operating systems and test the malware samples on them. And viewing this gives us valuable insight into how malware operates and the type of harm it may cause. And if you take the reverse engineering malware in a real world scenario, so consider a scenario in which a security analyst has identified a suspicious executed file on a Windows system that appears to be communicating with the remote server. The analyst suspects that the file is a Trojan malware and wants to analyze it to determine its behavior and steps to remove it from the system. The possible steps like obtain the executed file. The first step is to obtain a copy of the suspicious executed file from the Windows system for analysis. And second one, we have to perform the static analysis. We have to use a disassembler such as IDA Pro or Ghidra to perform the static analysis on the executable file. So this can include some disassembling the code to understand the program structure and behavior and identifying any obfuscation techniques used by the malware to evaluate the deduction and perform some dynamic analysis. The analyst should also use a debugger such as OLIDBG or X64DBG to perform some dynamic analysis on the malware. And this can include debugging and tracing the code to identify how the malware interacts with the system and any anti-debugging techniques it may be using. And monitor the network traffic. We have to use a network analysis such as Wireshark or TCP dump to monitor the network traffic generated by the malware. And this can include identifying the IP address of the remote server the malware is communicating with and the types of data being sent as well as received. Okay. And next one, identify the malware functionality. So here identifying the malware functionality is that based on the information gathered from static as well as the dynamic analysis, the next step to identify the malware's functionality, such as analyzing the amount of damage it can causes, or how it communicates with the command and control server, and whether it uses any rootkit or any anti-interaction techniques or something like that. Okay, next one, to develop a remediation plan. Post analysis, develop a remediation plan to remove the malware from the infected system and prevent it from spreading to other systems. And this can include updating the antivirus software or patching the vulnerabilities exploited by the malware and educating end users on how to avoid malware infections in the future. Okay. And next one, for reverse engineering malware is a complex and challenging task, and that requires some technical expertise, the use of some specified tools. Okay, so in this article, so we will explore how static and dynamic analysis techniques suit some different use cases. Okay, and a common approach to gain valuable insights into the behavior of malware to use both the techniques together. So besides choosing the analysis techniques and tools, here are some additional points to note before you use the reverse engineer malware. The first one is that ensures that you have the appropriate technical expertise before attempting to analyze the malware or conduct the malware analysis in a secure and isolated environment that is not connected to any production systems, or to use some multiple techniques to get a complete picture of the malware's behavior and functionality. Stay up to date with the constantly evolving tools and techniques for malware analysis and defense, and keep the detailed notes and documentation of the analysis process for information sharing and replicating the analysis. So while it's difficult to predict the future of cybersecurity, it's unlikely that we ever completely eliminate the threat of the malware. So as sorry, so as our technology continues to advance, cyber criminals will continue to find new ways to exploit the vulnerabilities and gain some unauthorized access to systems and data. So ultimately, a world without malware may not be entirely possible, but by taking some proactive measures or some safety measures to improve our security posture, we can significantly reduce the risk and impact of malware attacks and make the digital world a safer and more secure place. Okay, so these are the techniques of reverse engineering malware. Okay, so next one we are gonna discuss the reverse engineering in the context of a Linux system. Okay, so here it involves analyzing and understanding the inner working of software, hardware, or systems to gain insights into their functionality, structure, and potential vulnerabilities. So this process is crucial for cybersecurity, malware analysis, and software debugging. So this Linux system, with their open source nature and powerful tools, provide an excellent platform for the reverse engineering. So that is what they mention here. So it involves analyzing and understanding inner working of software, hardware, or the system to gain some insights into the functionality, structure, and potential vulnerabilities. Okay. And if you take, so this process, is crucial for cyber security, malware analysis, as well as for the software debugging. And here also we have, before going to this where we can apply, it also involves some static as well as dynamic analysis. So here, examine the resembled code of a program without running it to understand its structure and logic. And dynamic analysis, analyzing the behavior of a program while it's running, often using some debuggers to step through the code and observe the variables. And the tools used for some Linux engineering, like it offers some specified tools like Ghidra. So Ghidra is what we mentioned is that a powerful open source and cross-platform reverse engineering framework. And second one, IDA Pro, a commercial disassembler and debugger known for its comprehensive features. And third one, Radar 2, a free and open source framework for analyzing the binary files, offering a command line interface and scripting some capabilities. And next one, like GDB, that is JNE Debugger, a versatile debugger for examining or program execution and memory contents. And RMNX is that a Linux distribution specifically designed for reverse engineering malware, offering a collection of pre-configured tools. And Wireshark, a network protocol analyzer used for capturing and analyzing the network traffic traffic, which can be helpful in some reverse engineering communication protocol. And other tools like EDB debugger, JavaSloop, JDGuide, Dex2, JAR, and others offer specialized functionalities for reverse engineering. Okay, so where it is applied? So first one, we know like it is applied in malware analysis. Second one, software security. Third one, hardware reverse engineering. And fourth one is that protocol analysis. So malware analysis, understanding the behavior and functionality of malicious software to develop the defenses. And software security, identifying the vulnerabilities in software to improve its security posture. And hardware reverse engineering. So here, analyzing the embedded system and firmware to understand their operation, and protocol analysis, investigating communication protocol which is used in various systems, including the IoT devices. Okay, and apart from that, we know that this reverse engineering, it's also applied on various in Kali Linux. Like, yeah, have you heard of Kali Linux? I don't know, but that plays a major role. So it refers to the process in which we analyze and deconstruct the software binaries or system applications so that we can understand their internal structure functionality. And examples of reverse engineering in Kali Linux is that by using some Gitra, IDA Pro, Red Hat 2, we can able to have some system administrator which notices an application. They have no background knowledge of they can disassemble, analyze, or review the application to learn how would structure and identify the components incorporated it. Okay, and how this works is that as we have discussed, like static out assembly, decompilation, debugging, patching, recompilation, and then techniques. Okay, so static also, which involve like disassembler, the same thing which we have discussed in Windows is applicable. So disassemblers, you have to open the IDA Pro. First, you have to load the binary file, and we have to use a graphical interface to view the disassemble the code. And you have to apply the built-in debugger to set the breakpoints or inspect the program. And Gidra, it is a free open source which was developed by NSA. We have to launch it, and you have to create a new project, and we have to import the target binary, and the Gidra will be analyzing it automatically. And second one, Radar is lightweight open source, and this for this you have to install the Radar 2 from the official website. Okay, so once you have entered, there will be some command like AAA is list symbol or AFL, PDF, okay, PS, okay. For that, we have to first understand the assembly language fundamental. What's the x86 or x8664 or OPJ dump for analyzing some executable file. And same as that for dynamic reverse engineering also. Here it uses some debuggers like JDP or LLDB, and LLDB is nothing but it's a debugger for LLVM based programming languages, offering a model interface and advanced feature for Mac OS as well as Linux systems. And system call phrases, we have to use the command S phrase followed by the binary field. And analyzing the memory usage, we can use some run valgrid followed by the value. So it detects the memory issues during the execution. What are the reverse engineer specific target if you take us that? First one, Android reverse engineering, like APK tool for decompiling and recompiling Android APK files. And second one, like Dexterjar, it's a tool, it's also used for Android application analysis. And next one, JD guide. It's a graphical user interface tool designed to decompile the Java class files. And iOS reverse engineering tools like FRIDA enable dynamic instrumentation and runtime analysis of some iOS application. And in Java reverse engineering, we have to use JAD, a lightweight Java decompiler for static analysis, and JEB decompiler, a commercial tool for analyzing the Java applications and advanced reverse engineering concepts. We can handle some obfuscation techniques to reverse engineering by hiding the true intent of the code. Tools like Ghidra and Radar 2 can help to de-obfuscate the code with their compilation and some analyzing capabilities. Okay, like Binary Ninja is there, or OLEDPG. Okay, so in Kali Linux, it works with most probably like cybersecurity professionals only use. They'll be using like Radar GDP, APK tool for Maven to Android app reverse engineering processes. Okay, so that is why we are applying this reverse engineering. And next one, we will discuss what are the benefits of reverse engineering. So first of all is that it's a security enhancement. Second one, innovation and improvement. Third one, debugging. And last one, knowledge acquisition. Security enhancement, it helps to identify and fix the vulnerabilities in software and systems. And next one, innovation and improvement, which provides the insights for developing new features or optimizing the existing software and understanding the competitor products. Okay. Third one, like debugging, it aids in identifying and resolving the bugs in software and hardware. And last one, like knowledge acquisition, which deepens the understanding of the complex systems as well as the technologies. Okay. And if you take like drawbacks, so if that is good in the sense, so most probably it will be having some like concerns will be there. Okay, first one, intellectual property infringement. So reverse engineering can infringe on patents or copyrights, and trade secret product being analyzed is protected. And violation of terms and services, like many software licensing agreement explicitly prohibit the reverse engineering concept. And next one, like circumventing technological protection measures, or by bypassing the encryption or other security measures to reverse engineer software, which can lead to some legal repercussions. Okay, like reconstruction errors or case obfuscation and encryption, or complexity on some modern systems, and incomplete understanding. Okay, and we have to focus on the existing design or the potential for the limited creativity or the dependence of the original product quality. Like the quality of the reverse engineered product is inherently limited to the quality of the original. So all those things comes under the drawbacks of it. So in this particular video, we have discussed about what is meant by reverse engineering and why it is commonly used, and what are the various, or why need we going for this reverse engineered malware, and then what are the techniques for reverse engineered malware, like static analysis as well as dynamic analysis, and its benefit, limitations, or when to use, okay, such things. And in static analysis, we have discussed about the disassembly or the decompilation, symbolic execution. And similar to that, in dynamic analysis also, we have discussed on the debugging and tracing, memory forensics, emulation, and sandboxing. Okay. And so what are the key aspects of Linux reverse engineering is that, like Linux concept, we have used the tools, what it is used, and where it is applied, and what are the advantages as well as what are the drawbacks, and what are the real-time scenarios. Okay, so real-time scenarios, as we have discussed, is that in Kali Linux and how about like only DBG, okay, I read our X64 all such cases we are using. Okay, and apart from that, the potential risk. Okay, since one of the primary risks is that potential exposure sensitive code. If you are just passing the sensitive code, in the sense automatically it will be degraded, right? The competitors or the hackers, which can dissect an application to uncover the proprietary algorithms or the data, which may be replicated or used to determine or undetermine the original product integrity. So that also we see, and this is generally legal, but in some security laws similar to some individual developing, it is considered an allowed method to discover a trade secret. So that is what we have discussed. Because the patent owner has exclusive rights to use, own, or develop the patent. Reverse engineering is not a defense. So thank you all. I hope this video on reverse engineering on Windows and Linux system will be very useful. We will see in the next video. So thank you all.